Hey guys, so tonight we're just going to do a few questions that'll help pray for your test. So this is test review day 1. I'm going to go ahead and put the answers up before I start each problem. This way if you get the answers correct, you can just go on to the next problem. All right, for number 1, the perimeter of the quadrilateral is 40. All right, if you did not get this correct, let's go ahead and go over it. So we're given that points U, D, I, and T are points of tangency. So this tells us that all of these segments around the circle are tangent segments. We're given that the length of QA is 10. And DR is 4. We're also given that LI is 6. And QU is 7. Okay, so since these are all tangent segments, we can use that rule that we learned on Friday or Thursday night about tangent segments. And that says that if you have tangent segments that share an external point, those tangent segments are going to be the same. So around angle R, both of these segments are going to be 4. Same idea around angle L. Both of these segments will be 6. And then same with around angle Q. Both of these are going to be 7. So the only thing we don't know is what's going on around angle A. So I'll just put 4 tick marks here. 1, 2, 3, 4. 1, 2, 3, 4. But we can figure it out. How do you think we can figure out those little segments? Well, we were given that QA is 10. So 10 minus 7 is going to give you 3. So this length has to be 3, which will also make the length of AD 3. Now you guys can just add up all of your sides and you can get your perimeter. So you can, I already gave you QA as 10. If you want, add up A to R, which would be 7. Add up L to R, which would be 10. And then add up Q to L, which would be 13. Total would be 40. All right, the answer for number 2, the measure of angle CBD is 99 degrees. If you did not get this correct, let's go ahead and go over it. So you guys are given that arc AC is 88 degrees. You're also given that arc ED is 74 degrees. And we're trying to find the measure of angle CBD. I'll put a little X here. This was actually a very common missed quiz question. So let's talk about this one. When you look at angle CBD, it's not a central angle, not inscribed, and it's also not a CT angle. So this is one of those scenarios where this is an angle inside of a circle. So when you have an angle inside of a circle and you're given the arcs, you're going to end up adding those arcs and taking half. So we definitely want to use this equation. The inside angle equals 1/2 arc 1 plus arc 2. But you'll notice that the angle I gave you doesn't correspond with these arcs, because the arcs that you're supposed to use with the angle is the arc that the angle opens up to. So technically, I would need to know arc CD, and then since I have a vertical angle on the other side, I would also need to know arc AE. Well, I don't know any of those arcs, so that's not going to help me. So instead of solving for angle CBD, I might have to solve for a different angle first, and then go back and find angle CBD. I can actually solve for this angle that's right next to it. We'll just call it Y, angle CBA, because the 88 and the 74 go with that angle. So I'm going to solve for Y first, and then that'll help us solve for X. So my angle is going to be called Y. I'm going to add my 88 with my 74 and take half of it. So 88 plus 74 is 162. Take half of it. Y is 81. So on the quiz, when I was grading it, a lot of people put their final answer as 81. However, that's not the angle we're looking for. We're looking for angle CBD. So how can we get angle CBD? Well, we have a linear pair. So you can just do 180 minus that 81, and that's going to give you the 99 that we're looking for. All right, let's look at number 3. So the answer for number 3, the measure of angle LTS, is 131 degrees. All right, if you did not get this right, let's go over it. So we're given that LP is a diameter. So right away you should be thinking, okay, this is cutting my circle into semicircles. I might end up using that. We're given that the arc of SP is 67. And arc MP is 149. And we're trying to find angle LTS. I'll put a little X there. Okay, so this is pretty much the same thing as problem number 2. You do not have a central angle. You do not have an inscribed angle. You do not have a CT angle. Again, this is one of those interior angles where it's going to equal 1/2 of arc 1 plus arc 2. But again, you need to know the 2 arcs that go with the angle you're looking for. So the 2 arcs that I need would be this one here, which is LS, and then the vertical angle of X is over here at MTP, and I would also need to know the 149. So that we have. So we just need to figure out this missing arc, and then we're set. So how do you think we can find that missing arc? Well, we were told earlier that we have a diameter. Diameter splits the circle in half. So the measure from L to P is going to be 180. So now we can do 180 minus that 67 that was given to us earlier. 180 minus 67 will give you 113. So we can now replace this arc with 113. And we can plug in our information. So our angle is X. I'm going to take half, and I'm only adding the 2 arcs that go with angle X, and that's the 113 and the 149. So you're going to add 113 plus 149, which is 262, and then you're going to take half of it, and you'll get 131. Okay, the answer for number 4 is a decimal. It's going to be around 20.8. So let's talk about this. We're given that BD is a diameter, and it is perpendicular to a chord. That's actually a really big hint as to how to start the problem. So the diameter and the chord AC are perpendicular at E. So that means we have a right angle. We're given that from B to E, this whole length here is 18. And we're also given the length from E to D, that's 6. We're trying to find the length of AC. I'll just call that whole thing X. Now, let's talk about those center properties that we learned. If you guys remember the center properties, there were 3 of them. One of them talked about chords being perpendicular to the center. That was property number 2. If you remember what property number 2 mentions about the chord, it says that the chord gets bisected, which means it's going to be split in half. So I could draw tick marks from AE to EC, and those are going to be the same. So if I can figure out one of those, then I can just add them up, and I'm going to get X, my total. So what I'm going to do right now is I'm going to erase this x. I'm going to call this x, and this will also be x. And then to find AC, I'll just add them up. So how do you think we can now find x? Well, you'll notice we've been given segment lengths. Anytime we're given lengths, we want to talk about those equations that we learned. So these lengths are inside the circle. So if you remember, we're going to take the product of chord 1, and then we're going to equal it to the product of chord 2. So if I take a look at my first chord, I'll just highlight it in red. The diameter, it's made up of 18 and 6. So I'm going to multiply those together. And I'm going to set it equal to the other chord and its 2 parts, which end up just being x and x. And now we're going to solve. So we're going to get 18 times x, which is 108, equals x squared. We're going to take the square root of 108, and that's approximately like 10.4. So that represents x. So to find AC, you're just going to have to double this, times it by 2, and that's going to get us the 20.8 that we're looking for. All right, let's look at number 5. This one's pretty straightforward. We're just identifying the following parts. So I'll just go through it. The center is M. There's one diameter, JC, but make sure you put the segment bar above it. There are 3 radii. One of them is JM. Again, make sure you have the segment bar above it. The other one's MC, and the third one is MB. There are 2 chords. A diameter is a chord, so JC with the segment bar, and then also AB. And then we have a tangent line. That's the hit and run. So the hit and run starts at G and it goes to K. When you guys are labeling the tangent line, since it literally says line, make sure you have that line above it. If you don't have that line, it's wrong. Point of tangency is just where is the hit and run. So the tangent line hits at H, so point H. And then secant line, that's a line that's passing through the circle twice and then it keeps going. That would be line ED. And again, it says line, so you have to put the line symbol above ED, otherwise it would be wrong. Okay, number 6. So the answer to adding the measure of angle DLR plus angle DSR is going to be 189. So let's go over this. This was also a very common missed quiz question from last week. So we are given that arc DR is 126. We're trying to find some angles added together. So let's find the first angle, DLR. So I'm just going to trace that. Okay, angle DLR. Well, what kind of angle is it? It's an inscribed angle. And what's the rule that we learned for inscribed angles? It's going to be half of the arc. So this angle is 63 degrees. So right away, I'm just going to plug in a 63 here. And now we're just going to look at angle DSR. I'll actually do this in blue. So when you guys look at angle DSR, you'll notice it hits the center, which is S. So it's a central angle. What do we know about central angles? It's going to be the same as the arc. So this is 126. So you're simply adding, and that's where you get 189. Okay, last problem. Finding the length of AB. This is going to be a decimal. It's approximately 10.6. So let's talk about this one. So you're given that the length of EC is 12. Now you're also given the length of DC is 4. And then the length of AC is 14. We're trying to find the length of AB. I'll call that x. So again, you guys will notice you've been given lengths, okay? So we have some secant lines, and they're outside the circle. So we're going to use that equation of taking the total length of one secant line, timesing it by its outer piece, and we're going to set it equal to the total of the other one times its outer piece. Okay, so let's take a look at the first one. I'll just highlight it in red. Okay, when you guys look at this secant line at the very top, we're given the total. That's 14. But we're not given its outer piece, BC. I don't want to call it x because x is already representing a different length. So let's just call it y. Okay, now we're going to set that equal to the total of the other secant, which is 12, and its outer piece, which is just 4. Okay, let's do just some algebra here. So you're going to get 14y. 12 times 4 is 48. And we're going to divide, and you will end up getting y is approximately like 3.428, but we'll just say it's about 3.4. So if you know this is now 3.4, how does that help us find AB? We can just subtract 14 minus 3.4, and that gives us our 10.6. Okay, so these are going to be like similar test questions. Let me know if you guys have any questions. Have a great night.